Okay, in this video I want to talk about pedigrees. Okay, now I'm not going to be talking about the dog food that you see on TV ads. This is something else. So humans take a long time to breed, right? So we can't really study human inheritance using Mendel's method. So Mendel's method for human inheritance is a no-no. Okay, instead we use things called pedigrees. No idea what they call them, pedigrees. So pedigrees are families, okay? They're studied and analyzed, okay? And family pedigrees basically trace, so by definition they trace specific genetic characteristics through 3 or more generations, gens. It's basically a pictorial family tree, right? Here's a better way of saying it. Pictorial family tree where individuals who show a particular disease or characteristic are marked on it. Okay, that's another way of putting it. Now here are the symbols used in drawing pedigrees. There are different ways of expressing them, but this is basically the most basic general way of doing so. Okay, so a male is given a square box. So that's for male. Okay, and it's worth sort of committing this to memory if you can. So a male is in blue. A female is basically a pink circle. Okay. Now, a male who has a characteristic or disease is basically is a different color. It's basically the same box, square box, but in a different color. So purple usually. So male with characteristic, okay, or disease or whatever. Now, a female that's deceased, and this I think applies to males as well. A dead female has a line going through it. So female deceased. Now, identical twin boys is pretty straightforward. It's basically just 2 boxes, so 2 males. So coming from the dad and the mum here, up here, and they're connected with a line in between, okay? So they're identical twin boys. Now, for girls, let's say if they're non-identical twin girls, you have 2 circles that are not connected, okay? So they're non-identical. So these are called Siamese twins, I believe. Okay, these are identical twin boys, these are non-identical. Okay, so that's just the basic symbols used in drawing pedigrees. Okay, moving on. I'll show you how we apply these in practice. Okay, here's a very simple, straightforward pedigree. So let's say we have a female. Remember, females are pink circle. Pink and blue, I mean, they're pretty standard colors used for male and female. So if you ever forget what color they are, just think of for pink as female, blue as male. Okay, so I'll just draw some letters here just to remind you. Pedigree trees don't usually have letters, so I'm just drawing these for your own benefit. Okay, this is generation 1, gen 1. Okay, sometimes they just leave it as 1 instead of writing the gen. Okay, so what do these 2 do? They mate and they give off, let's say, a couple of offsprings. Okay, this is an example. Okay, there are many ways of drawing this. So let's say they give a female and they give off 2 males. This should be in pink, sorry. Okay, so 1 offspring, 2 offspring, 3 offspring. Offsprings are shown in birth order. Okay, so from the firstborn, secondborn, thirdborn. That's how it goes. Okay, this is gen 1, this is gen 2, second generation, right? So I would be here in my case. So parents gave birth to me, then my younger brother, then my younger sister. Okay, but I'm not a girl, obviously. So basically pedigrees as well, I should mention this. Pedigrees show transfer of inheritable characteristics from one gen to another. Okay, inheritance. That's all it shows. Now let me show an example of a pedigree showing how a characteristic is transferred from one gen to the next. Now there's many ways of drawing these, okay? All right, here we go. I'm going to show you a sex-linked inheritance scenario. Okay, let's say we have a female, and let's say we have a male with a characteristic. Okay, could be a disease, could be anything. I'll leave it as that for now. Okay, they mate, right, and they give off a male with a characteristic. They give off 2 females. Okay, so let's call these 1, 2, 3. Remember, they're the order that they were born in. Let's write 1 here. 1 for generation 1, 2 for generation 2. Now, let's say 1 and 3 copulate. Okay, they mate with someone else. Okay, the girl mates with the boy. The male here mates with a girl. Okay, and they produce their offspring. Now, here in this case, these 2 don't have any characteristics, any diseases or whatever, but they give birth to a male with a characteristic. In this case, we get this. Let's say these 2 copulate, they reproduce, and they give a male, and they give off a female. Okay, this is the 3rd generation. 3. Okay, 1st, 2nd, 3rd. 1, 2. The male's born first, and the female. Okay, and there's only 1 male here. Now, the offspring inherits a characteristic or a condition in this sex-linked inheritance scenario, right? Now, the pedigree for the disease called hemophilia, so spell this correctly. Okay, this is called the bleeder's disease. Okay, I had a family friend who died from this when he was very young, very sadly, this was 40 years ago, as I've been told by my family friends. Bleeder's disease. Okay, people with this disease have a defective gene. Okay, and as a result, they lack a particular blood clotting chemical. So this poor little boy basically bled to death when he had a cut. They couldn't get him to the hospital in time. Died tragically. Okay, so this is basically an example of a pedigree for someone with hemophilia. Okay, so blood clotting doesn't work in this case. Okay, so let's say he's got the blood clotting, he's got hemophilia, gives birth to someone with hemophilia here, but none of these offspring get it. This guy cops it. Okay, so it's genetic. Okay, that's why it's called sex-linked inheritance. This guy inherits it from his granddad up here. Okay. Very tragic condition. Okay, and I should also mention that those affected by the disease hemophilia are male in that case. Okay, here's another example. Let's say we have another example of a pedigree. We have a box, a male and a female. They copulate, they have intercourse. They give birth to a female, number 1. Then they sadly give birth to a male with a defective condition. And they also give birth to a female with a defective condition. So I should also have mentioned that a female with a defective condition is basically coloured in. Okay? If you see a male or a female coloured in, a box or a circle, they've got a condition. So that's Gen 1. Gen 2, okay, let's say the female marries a male and they mate. Then they have a female who's got a defective condition. And they have another female who doesn't have a defective condition. Let's say the male here meets a female. They have I should have drawn this first, sorry. They have a female and a male. Okay, Gen 1, Gen 2, Gen 3. Okay, here's another example. So in Gen 2, okay, an unaffected male produces an affected female. Okay, this indicates that the characteristic is caused by a recessive gene. Okay, recessive gene is usually associated with females a lot of the time. Okay. Okay, both parents are heterozygous. Okay, so the two alleles, remember, are different. Okay, this is a result of chance sometimes. Now, pedigrees basically, that's another example there, showing how without a parent having a defective gene, you can get someone with a defective gene, okay, through recessive genes. I should also mention that pedigrees help genetic counselors, scientists, to identify which individuals in a family are at risk of either inheriting a genetic disorder or being a carrier for a disorder. Okay, and that's pedigrees in a nutshell.